basically, what the design is and what are the things which are involved in the design at a very high level. So we will be, inshallah, trying to talk about this and complete this set of lecture and move into the actual design concepts today, inshallah ta'ala. So far, in addition to the first lecture, for this half of the lecture, we talked about the importance of the design on Tuesday. And we also talked about what's the difference between architectural and detailed design at a very high level discussion. Now, there are quite a few of us who have joining us today because, mashallah, our classes have grown significantly. So just for them, to quickly recap for them, what we have done in the first two lectures is that basically, we looked at different process models, and we said the waterfall model or incremental model or agile. All of them involve design in one shape or another. It all depends on the input you have, right? Sometimes your input will be a complete set of requirements, right? In case of a waterfall model, or you can have smaller chunks of requirements and you design them and you evolve your design. Regardless of which process model you're doing, the design activity is there. But of course, this depends on the input you're receiving. So this is the first thing we learned. And the second thing we did is the other day on Tuesday, we talked about, an architecture design is important, and there are usually two phases of design at a very high level. One is your architectural design, and the second one is your detailed design. They go hand in hand. Architectural design is all about, overall structure of an application, and detailed design is all about, further refining those structures or components into smaller and smaller units. Both of them are driven through requirements. So this is something we talked about the other day. Today, we will just try to finish this half of lecture from a discussion perspective. We will talk about, structural, and relational systems. So we'll talk about, how we can functionally decompose your systems and how the database designs are done. Again, this is not a database course. I'm just going to talk about this to make sure we have a and a better understanding of overall structure of our application, and understand that design involves multiple steps. Let me jump straight where we stopped. Maybe I can come back to this picture. And for us who are joining us today, so you're always going to have requirements. Now, depending on the process model you're using, either you will take all of these requirements or you'll take a part of them, and then you use this information to come up with your architectures. Of course, especially for architectural design, your decision might be influenced by your non-functional requirements. So you might have more influence on design architecture of your system based on non-functional requirements as compared to functional requirements. Because, for example, if you're looking for a certain kind of performance or you're looking for a certain kind of security, one architectural option or structure might be better than the other one. And this is what the whole idea of design is, that you don't come up with one solution just in one go, but actually in reality of the world, basically, you need to go on and look at your alternatives and select the one which is the most appropriate alternative for your system. So far, so good?
Doctor?
Yes.
Yes, please go ahead.
What can an architecture be? Like, what is it?
Good question. Now, as I said, in inshallah on maybe third or fourth week, we'll really talk about architecture, and I'll show you all different options. But since we are having a discussion here, architecture is about the structure of your system, your components, right? In other words, whether my system, and I'll talk about a very simple case here. Like if I'm developing a mobile application, right, like a hunger station, right? Then I have to think about the structure of the application, whether this application will be a client server application, right? Whether I will have one server and multiple clients, whether I will have multiple servers and multiple clients, where the database will be located, will it be, what kind of database we'll have, what kind of, the communication, the network communications they will have, what kind of protocols we'll be using. All of this is your architectural decision. Okay.
Yes.
And detailed decisions are more like your class diagrams, your sequence diagrams, your inheritance, polymorphism, all of those concepts.
Clear.
And together, this is design. Now, what are our architecture types? How we select them? Which ones are better for which solution? Just bear with me, inshallah, for 1 or 2 weeks, and this is exactly what we're going to talk about. Right? And hopefully it will become more and more clearer as we move along. Okay. So I think we talked about this, and we looked at this, and we talked about this. This is where we stopped the other day. We said that in a real, sometimes in an ideal world, we'll say that we will have a design, all work done. All programmers have to do is go and translate this into an actual code, this is true, but this never really happens like this. It's not like programmers just take a design and implement it 100%. In an ideal world, you like that to happen. In reality, the world doesn't happen. So basically what happens is that they also go on and make suggestions for the designs to be improved, because some of these things might not be practical, or will not be right, or may need to be changed based on your hardware or whatever other constraints. So they basically keep going back and forth, and your design keeps evolving as we move along. Is this point clear, guys?
I have a question.
Yes, go ahead, please.
So waterfall model is bad because we will go back to the design if there is something wrong with it.
Absolutely, absolutely. This is the biggest limitation with waterfall model.
Mm-hmm.
That's why, yeah, that's why usually we don't, recommend that nowadays, right? Unless there's some very specific case where your things are so clear, your requirements are so stable that you can just design it.
Yes, thank you.
You're welcome. So now, just to complete the discussion before we dig into real stuff of design, I'm going to show you functional decomposition concept. Now, the functional decomposition concepts are the reason I'm talking about this is that, not all programs are written as object-oriented programs, right? This dates back to our structural programming. And even nowadays, people are doing structural programming, right? Or functional programming. So, for example, web applications, mobile applications, it's not necessary that they are written using object-oriented code. For example, nowadays, the different, hybrid mobile application environments or frameworks, React Native or Flutter or many others out there, it's not necessary that, all of them will be object-oriented. Okay. Some of them actually are, or most of them are support functional programming, and some of them are functional in nature. Anybody has used any of these mobile application development environments?
Yes, I'm using Flutter right now.
Okay, so how's your experience so far?
Very good, excellent. But in website, it's not really good because it's in beta phase.
True, 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 true. So, are you writing functions in it and doing kind of a functional programming in it?
Yes, I make functions and classes and everything like Java, just like Java.
Yes, yes, exactly. So, uh, sometimes some of these languages use functional decomposition as well. So basically what happens here is that whole idea is, and this idea is again applicable to object orientation as well, is that basically you have a function or a module and you try to decompose this function or the larger function into smaller modules, right? And in other words, these smaller modules will give you a larger module. Traditionally, the modules are other systems in a sense, or procedures that are called by a main module, right? Like your main function in C or Java or so forth, right? And of course, what you do is basically refine your system into smaller submodules or subfunctions. So far, so good.
Yes.
Yes.
Perfect.
But I have a question.
Go ahead.
This will make the process slower, right? If there is too many functions and something like that.
Yes. It will have an impact on the performance. Absolutely.
Yes.
Absolutely. And this is where that's why we say that sometimes non-functional requirements play even bigger role, because then it depends on how you decompose them, how you structure them, right? Or you look for certain architectural models which are better suited for enhancing your performance. And that's why you have to come up with multiple alternative designs. You cannot just, unless you're so experienced that you can in one go come up with a design, right? Which is always rare. So in other words, you're going to have functions, right? And once you're going to have functions, you need to decompose these functions, right, into smaller modules or smaller functions. Now, how to decompose them? You can have multiple ways you can do it, right? It's not just one way you can do it. For example, let's suppose a simple example here. Let's suppose we are designing a course registration system. And this course registration system has many requirements, but 4 of those requirements are as follows. That you're allowing or you have a task, or you have a function, or you need some functionality which will allow you to modify, delete students from a database, right? And you want to be able to modify, add, or delete courses from the database, or you want to add, modify, or delete sections from a course, from a given course, and at the same time you would like to somehow register or drop students from a section, right? So let's assume these are the 4 requirements you have. Now, this could be one way of decomposing this requirement into one main function and smaller functions. And then their further refinement. Does it make sense?
Yes.
Yeah, it's clear.
Okay.
Wait, Doctor.
Yes, please.
Is
Go ahead.
that function the same in the courses and student and section?
Say it again. I lost it.
Is add, modify, and delete the same function in student and courses and sections?
It's a good observation, right? So are they doing the same from a functionality perspective, right?
Yes.
Yes. So if let's say they are, then can we decompose them in a different way?
I think so. It's going to be only one method with
Yes.
some parameters.
Yes. Something like this.
Oh, yes. Like this.
Something like this, right? Isn't it? So
Yes,
so this is basically, some example, some simple case, just trying to show that, if you have this is what I said here. There are alternate decompositions, right? One can do this way, right? Another one of us can do this way. Of course, one design or one choice will be better than the other, right? For certain factors. And this is something we will learn in the course, that, how to structure your design in a better way, right? But for the time being, all I'm trying to show here is just to complete the discussion and say that, sometimes you have to come up with functions, and all you have to do is basically decompose these functions into smaller functions or modules. Okay. Everybody's comfortable with this concept so far?
Yes.
Okay. Now again, the focus of this course is not database design, right? But the reason I'm showing you the database design here is because most of our applications have database in it. And what you have, the structure in your database, has an impact on your design as well, right? Or in other words, if you have a certain kind of tables in your database, probably you need to to implement those functionalities in your classes or functions. Okay, and what you really have in your structure of the database is it has a direct impact on your decisions which you take for your design, especially for your classes or methods or attributes or functions, whatever the different abstraction level we are using. Of course, in the practicality or the reality of the world, there are different kind of databases out there. Most of the popular ones are your relational databases or something like MySQL or Oracle, right? Anybody has come across Firebase database?
Yes, of course.
Yes, absolutely. Of course.
Yeah, so how Firebase is different from a MySQL, for example?
I don't know, but what I know is Firebase is really amazing.
Absolutely, cloud-based.
You don't have to write SQL or write statements.
Yes, yes. So it's actually a non-SQL database, right?
Yes,
it's hierarchical
right.
in nature. Yeah, so it's hierarchical in nature. So it is not like a traditional Oracle or MySQL relational database. Now, the reason I'm raising it, and of course, inshallah, I'm very sure when you guys will be taking 417 next semester or next year, a bulk of you guys will be doing mobile applications and you'll be using Flutters and Firebases and all of this. So the selection of a database has an impact on this design as well. Okay. And if, for example, you go on and take MySQL or you select Firebase, it has direct impact on your design decisions as well. But actually, it is a design decision. And accordingly, based on the structure of the database you basically write the methods or functions or classes accordingly. Can you visualize this with me?
Yes. Yes.
Okay. Everybody on board with me here, right?
Yes. Yes.
Okay.
Yes, teacher.
Because this
Yes.
is the biggest challenge. I can't see you guys, so this is the biggest challenge here. Okay. So again, as I said, the reason I'm talking about database design here is just to complete the picture so that you realize that they have a direct impact on your design decisions as well. Of course, the actual designing of a database and how you do it and what are the different things involved in it usually are taken care in your database course. So, of course, in a very quick way, we know if as long as it's a relational database, it will have tables, right? And then tables will have records, and they will have information in terms of your entities, and they will also have information about their attributes as well. And of course, there will be primary keys, which are the unique identifiers, and you will always have some foreign keys which are used to connect different databases, tables, right? So for example, if you have a course table, then it will have a primary key which uniquely identifies each course. And if you want to make, for example, write a query, an SQL statement, which says that go and find me a student who has enrolled in 316 and also has enrolled in, I don't know, web development, for example, right? So you use these primary keys and foreign keys to go and search the records. So usually database designs are done at different levels. One at a conceptual or a data modeling level, and they usually use ER diagrams. How many of you have seen ER diagrams?
Me?
Yes.
We have.
Great. So
Some of us.
yeah, some of us. So it's just a way of representing your structure, and it's basically created to analyze your structure of the database, and of course it revolves around the requirements of your system anyway, right? That what kind of records needs to be stored, what kind of tables you need, what kind of functionality you need from a database perspective. And then you always have a logical design as well. So basically you take input as detailed ER diagram, you normalize it, You come up with schemas of it. Now, how you do it, this is beyond the scope of this course, right? But I'm just showing you the different steps you do in your database design. And relational schemas is basically nothing but a set of tables together with their foreign keys. So basically you draw ER diagrams, you come up with your schemas, and then you go on and implement it. And you have a physical design. Basically you go on and actually implement it. You say what kind of indexes you need to make your search fast, and you know, something like hash tables and something similar. And then of course you write SQL statements to go on and actually search the records. And at the end of the day, basically you go on and deploy it. So again, the message here is that because database have an impact on your other design structures, you have to keep in your mind what kind of relationships they have in the database side, what kind of records they have, what kind of, you know, tables you have. Of course, if you're doing a Firebase kind of a database, then it's not SQL. So basically you might not have something like this, like ER diagrams, but probably will have something like this, hierarchy. Okay. Now let me just show you an ER diagram here very quickly, just to complete this discussion. So I'm pretty sure you guys know ER diagram, or ones who have seen it. So basically you have entities which are usually represented as rectangles, and you can have weak entities as well, which are usually represented as double lines, but we're not going to go into these details. We're going to just look at a very, very high level concept here. And of course, the relationship between entities is shown as a diamond. And then you have attributes which are shown as ovals, and you can have multi-value attributes, and you can have, you know, identifying ones. Now, for example, tell you guys, I have an attributes, or for example, I have a entity called course, and course has an attribute called course number, and the data type is double, or type of this data is double. Will it has an impact on the way you do it in your actual system, classes, coding?
Yes, of course.
Of course. So they go back and this. So that's why I'm saying they have a relation. They have an impact on your designs, right? Okay. Now this is a very, very simple case here. Can someone help me? The one who is very familiar with ER diagrams can help me understand and say what exactly is happening here.
Yes.
Go ahead, please.
So we have an entity called course.
Yes.
And this course has an attribute, which is a number, which is here. It's a primary key, and then you have a title and the credit hours. Okay. This course has a relation, which is belong to, or a section is belong to a course. And that course and that section has an attribute the same as a course, and that section has a relation with the student which has the same as, which has an attributes. And this grade, I forget what does that mean.
So this basically grade belongs to this
relationship.
Yeah. Yes. So it belongs to this relationship, and you create them as a separate table.
Yeah, exactly.
Right. So basically, you know, you have courses and you have sections and you have students, and of course, each one have their own attributes, and then they have certain relationships with each other, and some of these relationships result in a certain new tables as well. Right. Now, if you have an ER diagram like this, can you come up with a basic structure of your class diagram, like a very basic one? It's the starting point.
Yes, of course.
Yes, this is why we do it.
That's exactly why we do it. How many classes you will have? Probably
3.
4, I think.
4, grade as well,
4.
maybe, right?
4, yeah.
Right, and then of course each of these class has its own attributes, and of course then you add on your methods and so on and so forth, right?
Doctor.
Yes, go ahead, please.
Did you say the 4th class is the grade?
It could be a grade because you might like to store grade somewhere, you know, it depends on the logic.
Okay.
Right? But this concept, I'll talk about this later, inshallah, in our class diagram as well. Okay. So this kind of summarizes our introduction, right? So I'm done with the introduction of the design here. I started off by giving you a quick overview about the processes and let you guys know that, you know, design happens in each process. It depends on the process, that what will be your input to the design. And I'll also give you an overview of saying that, you know, when someone says design, usually we're talking about at least two abstraction levels or two levels. One is your architecture level design, another one is your detailed design. When it comes to architectural design, it's again depending on your requirements, and it's usually non-functional requirements really play a big role there as well. And your detailed designs are of course reflected or impacted by your requirements and also your architectural decisions. And you know, when we are designing our applications, we need to come up with functions or methods, and we need to make sure that, you know, not everything is in one big function or a method. So basically, you try to make your systems more modular by dividing them or decomposing them. And at the end of this lecture, we looked at, you know, database designs just to complete the picture that yes, database have their own design decisions, and they use ER diagrams and schemas to do it. They have a big role and impact on our other design decisions because most of our applications are in one shape or another driven through their databases, and you know, they both go hand in hand. And this is actually, you know, I have experienced it myself from my industrial experience that this is really very common that in the beginning, especially in the starting phases of your application development, you know, your database design and your other design decisions are heavily interconnected, and they, you know, impact each other heavily, and they're you know, usually they could be different teams doing it, but they are really you know, very much in communication. So far so good.
I have two questions, Doctor.
Yes, go ahead please.
What's the benefit of function decompose?
Okay, the biggest reason we decompose our functions into smaller ones is that we want our systems to be modular, right? And when we make our systems modular, this means that if there is a change in one function, we don't have to, or we minimize the rippling effect of that change.
Yeah, fine.
Right, and this is something we will be using as a very important design decision.
Yeah, absolutely.
Right.
Yeah.
Okay. Now with this, we are done with the introduction, and not what I'm gonna do now is I'm gonna go on and actually talk about object-oriented design now, which is the actual, you know, part of the course, the main component of the course, right? Now, the concepts I'm gonna start talking about, I'm very sure you know the fundamentals of these concepts, okay? But I like your special attention here because some of these concepts I like you to be absolutely crystal clear about, because if you're clear about these concepts now, your the next phases of our design discussions will be absolutely clear to all of you. Okay, so it's an easy stuff, but I would like you to be absolutely clear about, you know, these fundamental concepts. Now, since this is a very important point, and when I'm usually physically lecturing, I really like involvement here. So to try to mimic that, I'm going to turn on my camera here so that you can actually see my expressions and see, you know, what is the importance of these concepts, and you know how you need to focus on these ones to basically understand this important, very important concept, right? You guys can see me?
Yes.
Yes.
Okay.
Yes, Doctor.
Okay. Now, of course, I'm not going to look at the camera all the time because I have a larger screen. I am using that larger screen to teach, right? But there are certain concepts I really want you to understand. Now, some of these concepts, you guys know it, to be honest, right? Because you have been doing object-oriented coding from 1 or 2 days. And I'm assuming here most of you guys have done actually 2 or 2 even, right?
Yes.
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 Okay. Perfect. Now, let's dig into it, okay? And let's see what exactly is happening here. Object-oriented programming languages is nothing new here. They've been there for more than 30 years. Most of the applications nowadays out there in the world are developed using object-oriented applications, right? And there is a reason for it. Of course, we know that it was not always the case. And people never used, from the beginning, people never used to write object-oriented because there was no object-oriented code or language in the beginning. People used to write procedurals, right? So they used to have long procedural codes. And even languages like assembly language or COBOL or Fortran, you know, they used to have no objects at all. They were straight procedural languages. I'm pretty sure you guys have taken assembly language course, right?
Yes.
Yes.
Right.
Some of us.
Some
Not all of us.
Not
Yeah.
of us. And did you find programming easy in assembly language, the guys who have done it?
No, it's more than
No.
One line in Java, it's 5 in assembly. How it could be easy?
Yes, absolutely. And then things are complicated, and when the systems are becoming more complicated, it's very hard to, you know, even imagine how you're going to do it, right? So object orientation came along, and the concept developed and started with this. With basically, actually, it started with C when they started having templates, and then the concept of classes came as part of C++, and then Java and C#, and as they say, the rest is history, right? Now you have Python, and all of them all have object orientation inbuilt in them. So the procedural languages were written in long procedures, right? And they used to contain a lot of functions and subroutines, and it really was becoming, you know, long piece of code. Often, if you have, you know, data at one place and logic at another, right? As programs become bigger and bigger, they become difficult to manage, because if I'm going to make a change somewhere here, for example, right, it may have a rippling effect all over the place, and then because of the lack of the modularity, it became really difficult to manage that, and hence object orientation came. So far so good?
Yes.
Yes.
Yeah,
Yes.
it's clear.
Yes. Yeah.
Okay.
Yes.
Of course, object orientation gained popularity. Now, this is, I believe you guys know this information, right? But I'm gonna just, you know, make sure that we are on the same page here. Do you agree with this statement?
Yeah.
Yes.
We agree.
Yes.
Organize programs into self-contained objects. So each one of these is an object, right?
Yes.
Yeah.
They're almost like several mini programs, correct?
Correct.
Yeah.
Okay.
We can say that.
Okay. Now, if I asked you what is an object, what you will say? Because this is something we have been doing from day one, right? What exactly is an object?
Group of attributes
It's a group of attributes, yeah,
and data.
and
And
data
functions.
and functions, right? Anything else?
It represents a real life thing.
It represents a real life thing, absolutely.
And they are all related to each other.
And they all related to each other, right? So basically, each object represents different part of an application, correct?
Yeah.
Yes.
And
Yes.
they have their own data and logic, right? So
Yes.
this object has its own data. This object has its own data. This object has its own data. Other ones have their own logic. Now, what is a data? When I'm saying each object has a data, what is it?
Strings, tables, arrays, lists, everything.
Everything. So the attributes, right? And what's the logic then?
maybe manipulation methods to the model.
Manipulation
The
methods.
Procedure,
Methods, right? So manipulation of the methods. Everybody is clear about these things. Like when someone says an object and he says object has a data and a logic, it's everybody's clear about this.
Yes.
Okay. And of course, we also know that these objects are not in isolation, right? They communicate with each other. So they talk to each other, right? They share data between them. They basically do method calls, right? And this is how the application works, right?
Yes.
Yes.
Okay. Now, can somebody give me an example, right? You know, if I say this is an object and it has a data, so we know that, for example, you know, when I'm going to create this object, I will have a constructor, and for example, for an attribute I will have a value 0, correct?
Yes.
Now, if I want this value to be changed to 1, what I will do?
Change it to 1.
How?
You'll be using logic, maybe.
Exactly. We will be using logic, right? So we'll be using logic, and then how this logic of this object is different from this? They are the same methods. How they are different then?
From outside, maybe it looks like the same method, but from inside, each model has a different implementation. Maybe, I think.
But imagine at the end of the day, if I have an add method, for example, right? And it takes a certain input, I. Now, how this is different from this?
The values are different.
Absolutely. The values are different, right?
Yes.
Everybody is clear about this important concept?
Yes.
Can you
Okay.
repeat it, Doctor?
Yes. So we just said a moment ago that we have these self-contained objects. They are like mini programs, right? They have two parts in it. They have their own data and logic, right? And when it comes to data and logic, data is very clear. Attributes. So for example, this object 1, i's value could be 0. Of course, in the beginning, i's value will be 0 here as well, for example, right? Because if it's a constructor which is making everything 0, right?
Yes.
Now, if I have an add method and I want this value to be added by 1, incremented by 1, for example, right? While for some logic, I want this value to be incremented by 2, right?
Okay.
Right? Or even 1, doesn't matter, even 1, right? Let me even say it, even 1. They are separate entities, right?
Of course.
And hence, they have their own. Of course, the value has incremented by 1 here, value have incremented by 1 here as well, but they are two unique different objects, and both of them have their own logic and data. Now, if you are not still clear, just bear with me, and I'm going to show you a very interesting example, right?
No, it's clear, Doctor.
Okay. Of course, they are not random objects, correct? We don't just create randomly objects, right?
Right.
Right.
We actually look at the problem we are trying to solve, right? Of course, right, isn't it? From a programming perspective, from a software engineer perspective, we have a problem at our hand. We have certain requirements on our hand, and now to solve that requirements, we're thinking about what kind of objects I need, right? What kind of entities I need in my system, right? And these objects usually represent certain real life things like, or entities like employee or image or bank account or video segment or audio segment, right? And this all depends on your problem, correct?
Correct.
Yes.
Right. And of course, remember, so far we know that objects have their own what?
Their own data and their own logic.
They have their own data and their own logic. Absolutely spot on. So object orientation concept provides a direct mapping between concepts and code. That's the strength of it, right? So the things you see in the real world, you try to represent them as source code, right? And you represent them as objects. And that's what you do, isn't it?
Yes.
Now, why I'm interested in talking about this today is because as a designer, unless you know this relationship, unless you're able to visualize this relationship, you cannot do design. Okay. Now, can someone help me understand what is an object now, right? What is an object? Because everything is focused on object orientation, right? Java is an object-oriented programming. Nobody says Java is a class-oriented programming language. C# is an object-oriented programming language. So the focus is on object. Exactly what is an object anyway? What exactly it is? Yes, we know it has data and logic, but what exactly is an object?
Okay, so an object is something like it's a unique. Like for example, when I say T-shirt, it's not an object, but like Fadi's T-shirt, that's an object because it has specific data in it. Cannot be like I cannot create two objects for the same thing, the same data, because that would be redundant.
Yes,
I don't know.
yes.
That's
Yeah. You're nearly there, to be honest. You're nearly there, to be honest. You're nearly there, to be honest, as a concept. Anybody else would like to say instance of a class? Yes, it's an instance of a class. Definitely, absolutely, it's an instance of a class. But then exactly what it is?
It's an entity that will have distinct features.
Yeah, so it's like an entity which has its own properties, right?
Yes, and properties that will affect other objects or relate to other objects.
It will relate to other objects because yes, we just saw that objects are not in isolation. They talk to each other, they share data and so on and so forth, right? Anybody would like to go ahead and comment on what exactly is an object?
I think
Go.
I think the object, it has own behavior
It has its own behavior, yeah,
and
absolutely.
attributes
It has
to
its own
react with another object and do it.
True.
Thank you.
You're welcome. Anybody else? Go ahead, please.
Can I give another example? It's a name that will describe a selection of data.
Yeah, okay. So it's kind of, yeah, I know what you're saying. Yeah, exactly. You guys are getting there. One last lucky last comment before we really talk about this. What exactly is an object?
Doctor.
Yes.
I think it mimics real life behaviors. You see behaviors in real life, and you try to mimic them into objects.
Yeah. So basically, we have some kind of a real life entities, right?
Yes.
And we're trying to show them and somehow model them. Okay. So let's see what exactly they are. Now I'm gonna use some examples, okay, here, right? And I'm gonna show you some stuff, and I'm gonna try to make this concept clear with these simple examples. Is Apple an object?
Yes.
Right. Absolutely, yes, true. What about this cup or a mug? Is this an object?
yes.
All right, absolutely, it is an object, isn't it? Now, subhanallah, nobody teaches us this as such, but from our childhood, subhanallah, we understand that apple is an object, mug is an object, right? We never get confused between them, right? Despite both are objects, correct?
Yes. Correct.
All right, so we know that yes, both of them are objects. At the end of the day, are objects, but apple is a different object, cup is a different object. Right? Now we'll want to develop this thinking process for us to become a good designer, actually. So we understand that their objects are separated from each other, right? Now, how you know that they are different from each other?
By their shapes, properties.
Different attributes.
different attributes, different shapes and stuff
Different
like that.
properties.
Different properties. So they have now. An important point here is that they have their own identity, right? That we know apple is different from a mug or a cup because they have their own unique identities, right? And we never get confused about this at all. So far, so good?
Yes.
Okay.
Yes.
Now, what about this? How many objects I have?
Two.
1, 2.
2 objects.
One object.
Two.
2 objects.
Now, why? Okay. Why 2 objects? Why not 1? Both are cups.
2 objects the same.
So how I know
objects
this
of the
is
same
different?
type.
You can fill one of them with water and one of them without water. You can see that they are different.
They are different, right? From a human thinking perspective, how we know that they're different? Because of what? Because of the identity.
One, the other will not change.
Yeah. So for example, the identity, right? We call them mug 1 and mug 2, right? Correct.
Right.
Yes.
Or this could be Muhammad's mug and this could be Ahmad's mug, right?
Right.
Yes. Right.
Right. So at the end of the day, both are objects. There are 2 objects, not 1 object. Okay, this is an important point to understand here, right? Yes, both are cups, so they are of the same type, but they are unique. There are 2 mugs, but they're not the same objects. Everybody is clear about this concept?
Yes.
Yes.
Right. So this is a very fundamental concept we are trying to develop here. Yes, you guys have been doing object-oriented programming from day 1, but we have to be absolutely clear about this as a concept because this is our fundamental first step for actually going and doing design here. Okay, so there are 2 objects. They are different objects. And the reason they are different is because they have
Their own identity.
They have their own identity, right? And we are never confused about them as such. Of course, this means each of these objects will have its own identity, its own logic and data, right? Got it?
Yes.
Yes.
Being an object has nothing to do with its complexity. This is the last thing, then we'll stop, inshallah. For example, we know that Apple is an object, correct? We also know that aircraft is an object as well. So is iPhone, right? As a concept of object orientation, we are never confused. Do you agree with me?
Yes.
Yes.
Right?
Of course.
And even we are not confused by saying that, one object may contain other objects as well. We are never confused about this point. For example, I can say to you, well, I'm going to use my iPhone. You immediately know what I'm saying, right?
Yes.
And then if in the second sentence, I say to you guys, hey, I think my battery is dying down. I need to go and replace my battery. You immediately understand this statement, isn't it?
Yes.
And you understand what objects now I'm talking about. I'm talking about a battery as an object now, right? Isn't it?
True.
Which is
Yeah.
part of the iPhone, right?
Right.
Yep.
So same thing happens to us in our source code and in object-oriented design as well, that sometimes we design systems only with simple objects. Sometimes we combine objects to create complex solutions. Cool.
Great.
Right.
Absolutely.
So I'm gonna stop it here. It's 10:50
That's great.
now. I'm gonna take a attendance now online and it's done. Come on. And then we'll stop it here, right? Because it's 10:50. Enjoy your weekend, guys. I'm still around if you have a question. Otherwise, feel free to leave.
Thank you, Doctor.
Thank you.
Thank you.
Thank you, Doctor.
You're most welcome.
Thank you.
Inshallah,
Doctor,
we'll use